All right. You can hear me, it sounds like. So thanks for coming to learn about Linux at TechEd. Linux on Windows Azure. So I think you're going to like the talk this morning because it is demo intensive. We don't have many slides, but we have tons of demos. We have demos. I'm going to do some demos, and then we have partners here from some of our distro partners. They'll also be doing some very cool demos. So in fact, what I'll do is I'm going to jump right into our first demo, so I can get it started while creating a virtual machine can take some time, so I want to get it started, and then I'll be able to come back to it after we go through a couple of slides. So the first thing I want to show you, oh, thanks for reminding me. Okay, cool. So first thing I want to show you is how easy it is to create and get a Linux virtual machine up and running on Windows Azure. So how many of you have signed up for the Azure preview, have gone to the new portal? Okay. All right. And how many of you have tried to create a virtual machine or gotten a virtual machine running? Okay. Excellent. All right. Okay, so it's very simple. Just click on New, go to Virtual Machine, from the gallery, and then what you see here is the set of what we think of as our platform images. These are the images that are available to you as a starting point, so that you can quickly get up and going. And as you'll see here, we have Windows images, and we also have a number of Linux images. And right away in the UI, what you see is that Linux is as prominently featured as Windows, which is in the spirit of our approach to supporting Linux on Windows Azure. We wanted to make sure that we provided a first-class experience for Linux, and that's our goal. So what I'll do is I'll pick Ubuntu Server as my Linux distro of choice. Give it a name. Save that for later. And that's it. So we have a Linux VM that's being provisioned, spun up. That'll take a few minutes. One thing that I'd like to point out is that I'm able to do this entire presentation while running Ubuntu on my laptop. So again, in the spirit of enabling Linux as a first-class capability on Windows Azure, we wanted to make sure that you could do everything that you needed to do in managing and deploying Linux on Azure without having Windows anywhere in your environment, if you've standardized on Linux on client and server. So go over here to my PowerPoint through the magic of Office 365 and talk a little bit more about why we set out to enable Linux on Azure and what we're hoping to achieve. So one of the things that we heard as we talked to customers, enterprise customers, in terms of defining the requirements for our IaaS release, we heard from customers that they have mixed workloads. They have a combination of Windows workloads and Linux workloads. And so in order for them to take advantage of the cloud, we needed to be able to support Linux as well as Windows. So it would be great to know how many of you have mixed workloads, manage mixed Windows and Linux workloads. Does anyone here manage just Linux workloads, no Windows at all? Okay, so that aligns with the motivation for us supporting this capability. So enterprise customers are our primary audience for the Windows Azure platform, but at the same time, in terms of leading cloud adopters, it's the smaller ISVs, it's the smaller development shops that are at the front edge of cloud adoption. And many of those smaller ISVs, they've standardized on Linux as their development platform. And so in order for us to have a credible and strong solution for enterprise customers, we needed to approach this in a way where we could be credible for ISVs as well. So we expect that we'll see some uptake from ISVs early on. That's what we hope anyway. And then over time, we hope that our enterprise customers will move over en masse, running Windows and Linux on Windows Azure. Also, in the spirit of our approach here, we intend to open source much of our innovation. So there's some work that we have done to optimize the Linux kernel when it runs on top of our hypervisor. Those drivers are already available under open source. And we have some integration work that we did in the form of a Windows Azure agent that enables Linux VMs on Azure. That's also open source. So you can grab those capabilities and you can plug them into your distro on your own. You can recompile them. You can look at the source code. You can modify the source code, just like you can do with Linux and OSS generally. So in terms of our roadmap, for our preview release, which shipped officially on June 7th, we're supporting 3 distros out of the gate. We're supporting Canonical's Ubuntu server distribution. We're supporting 2 flavors of SUSE, OpenSUSE, as well as SUSE Linux Enterprise Server, or SLES. And we're also supporting CentOS. It would be great to get a sense for what kind of distros you're interested in. How many of you are CentOS customers? Okay. How about Ubuntu? How about SUSE? Okay. Well, they're not on the list, so. How many Red Hat customers? I'm curious, since you mentioned it. Okay. All right. So we support a couple of different scenarios for the preview release. As I showed you in the demo, through the Windows Azure Gallery, through our portal, you can get access to what we think of as partner-curated images. These are the images that have been provided and tested by our distro partners. And so they're ready to go on Windows Azure. Optionally, you can also bring your own Linux distro. So we have instructions at the URL that's mentioned on this slide where you can go by using Hyper-V in your local environment. You can create a Windows Azure compatible Linux VM, and you can upload it into your storage account. And as long as it's one of these 3 distros, it'll be supported, and it should work fine. And I think that it'll be a mix. That over time, I think more and more customers will be doing all kinds of customization with their VHDs. They may the bring your own Linux option may become more popular over time. And so anyway, those are the options that are available for the preview release. In the future, what we're looking to do is to add additional distros. So there's a long tail of Linux distros out there, and we want to make it possible for any distro that a customer wants to deploy or that's available in the community. We want to make it possible to run those on Azure. And so what we're doing is we're investing in a community VHD repository. The idea is that we'll have a place on the internet where members of the community can go to upload their distros in the form of VHDs, and then customers can download those distros and be able to pick from and be able to rank them, rate them, and so on, so that the good ones will float to the top. And then that experience will expose up through our Azure gallery over time as well. In addition, enterprise customers expect enterprise services support, like patching and phone support. Those are some capabilities that we're working on as well for the future with our distro partners. Okay, so what I'm going to do now is go back to my VM. Looks like it's still... Looks like it's still booting That's one of the interesting things about doing live demos using the cloud, is that can sometimes be hard to predict how long things will take. So what I'll do while that's cooking is talk a little bit more about some of the capabilities that we've made available on the client side. So I talked about the fact that we want to make it possible for you to do everything Linux to Linux in terms of managing Linux VMs on Azure. And so one of the investments that we made is to take all of our PowerShell commandlets that are used to manage Windows virtual machines or Azure remotely via our REST interfaces, and we made equivalents for those that will run on Linux or Mac, and we implemented those binaries using Node.js. And so what I'll do is I'll give you a quick demo of how you can use the command line to manage your remote Linux environment on Azure. So Azure is the name of the top level scriptable Node.js component, and then VM is a parameter that asks for a VM list is a set of parameters that gives me the list of all of my virtual machines that are currently running. So there you go. The number of different commands are possible. You can create images. Everything that you can do through the portal is available through the Linux command line. And I'll show you some more of that stuff as we go. Depending on how long this takes. Huh. Let's restart it. Fortunately, I had the foresight to create a VM in advance. So what I'll do is I'll show you some of the, maybe that will come back. It'd be nice if it would. But anyway, so I have a pre-created virtual machine here. And so what I'll do is show you how easy it is to SSH in and make some changes. Optionally, you can use an SSH cert as well. I chose not to do that. So one of the things that you can do once you're SSH'd in is we're working with our partners to enable repositories, patch repositories for all of the distros that we support natively. And those repositories will be co-located with your virtual machines. So from within your VM, you're going to be able to, for instance, install the Apache stack. And that will be optimized. I already had it installed on this one, but anyway, the idea is that this will be optimized so that the performance is really really strong when you're running in a virtual machine on Azure, and that way you'll be able to do things like script the creation of multiple virtual machines and dynamically build up the stacks for those virtual machines on the fly. So you'll be able to spin up and compose hundreds of virtual machines all at once and then spin them back down. That's part of the power of the cloud. That's also part of the power and the composability of Linux running on our cloud. So I'm going to go and just make a quick change. This is my pre-cooked VM. Type in some random text. Now I can go back out, and the URL for that virtual machine is right here. And so that's, you know, it's that easy to get Apache up and going on Windows Azure. Okay, so what I want to do next is go through and show you how you can take advantage of the templating capabilities that we have in Windows Azure. So one of the things that is possible to do is to take a virtual machine, a running virtual machine, and then capture it out to an image that you can reuse for subsequent virtual machine creation. So what I'll do is this time around when I create a VM, instead of basing it on one of our platform images, I'm going to base it on one of the images that I've stashed away that I snapped from the virtual machine that we were just looking at. So I went over here to, instead of platform images, I went to the My Images folder, and I selected this, going to select this one pre-cooked image. And so I'll give it a name. Same process as before. And this time around, I'm going to select, instead of standalone virtual machine, I'm going to select that I want to connect it to an existing VM. And ultimately, where I'm going with this is I'm going to be creating a load balance set of web servers. And I'll be doing that by leveraging the software load balancing capabilities that are baked into the Azure platform. So I'm going to associate this new virtual machine with the one that we were just looking at. So that's it. So it's going to go off and it's going to associate these two virtual machines together and create a single cloud service that organizes them as a set. And then once this is up and running, I'll be able to show you how the load balancing works. Okay, so while that's going, I thought I'd give you a sense for what goes on behind the scenes when we're creating a new Linux virtual machine on Azure. So one of the first things I did is through the portal, I provided some basic information about the VM that I wanted to create. Again, this is all available via the command line as well as REST interfaces. Provided that information to the portal. And then what the portal does is it creates an ISO image that contains that meta information or config. And then it stores it in a temporary location in Azure in what we call a provisioning repository. And this basic approach to creating a Linux virtual machine is it's very similar to how we create Windows virtual machines. It's essentially the same experience. With some small variations for Linux. So then what we do is we grab one of whatever OS disk you picked through the portal. That's created, that's copied into the customer storage account. And then what you see here inside of this OS disk, you see what we call our ICs. These are the drivers that enable the guest operating system running Linux to efficiently access the hardware that we use to host the Azure platform. And then this little Martian-looking guy is the Windows Azure agent. It deals with making sure that Linux can run well and is compatible with with Azure. It manages the host name, IP address, NIC, that kind of a thing. Then we create a new virtual machine on top of our hypervisor. We create a cache VHD file. So the way that the storage works in relation to IaaS is that your data disks and your OS disks, they're stored in Azure storage, and they're accessed over our internal network. Optionally, you can have local temp files that are local to your compute for more efficient access of whatever temp files your app may need. That cache is then mounted into the virtual machine, shows up like any other mount point. Then the OS disk is mounted, and then optionally you can have a data disk that's mounted as well. The ISO is executed. Everything is cleaned up, and you're good to go. So that's what happens behind the scenes, and then we're up and going. Let's see where we're at on this guy. Okay, this one looked like it worked out better. So that's looks like there's a little bit more work to do there. So let me come back to the command line here. So one of the things that is kind of neat about oops. Pardon? Oh yeah, thanks for reminding me. So we can get all the shoot. Thank you. So we can get all the meta information associated with the virtual machine, and we can do that, and it'll spit it out in a sort of a tabular format. And then optionally, we'll spit it out in JSON form as well. Okay, let's go back. Okay, this guy is up and running. So now what I'm going to do is create a new endpoint. And just like I did before, I'm going to create a new endpoint, but this time I'm going to pick an existing endpoint that was created as part of this cloud service that's now associated with two different virtual machines. And I've selected that Azure will load balance automatically on port 80 into this new VM. And so then I can go over to the URL. And so eventually what you'll see is that once that VM is up and running or that port's open, then you'll start to see the round-robin load balancing between the two different virtual machines. The other benefit to being able to group multiple virtual machines into a single cloud service is that for availability purposes, you can organize them, if you choose, into different availability sets. And the notion of an availability set corresponds to a rack in one of our data centers. So the idea is that if you separate your VMs into multiple availability sets, if we lose a rack, you're guaranteed that the other virtual machine will keep going. And as you increase the number of availability sets, that increases the number of nines of reliability as well for your service. By default, for a single instance, when we transition to GA, we're looking at supporting 3 nines of availability. But that, like I said, that increases as you keep adding additional availability sets. So there it is. So that's the second VM that I created. And let's see here. Eventually it'll start ping-ponging back and forth. There it is. Okay, so that's the basic idea. That's what I have. So now I'd like to invite Christoph Thiel from SUSE to come up, talk to you about some of the cool stuff that they're building.
Is this on? Okay. Good. All right. So today I'd like to talk to you about SUSE Studio and how we have enabled SUSE Studio to help you build images for Azure. I'll talk a little bit about the SUSE Studio architecture after my demo. So I'm not sure. How many of you have heard about SUSE Studio before? Okay, some. That's cool. So what is SUSE Studio? It's an online service that we have had for almost 3 years now, which you can use to build images of our Linux distributions, that is OpenSUSE as well as SUSE Linux Enterprise. And what I've done here is I've actually logged into my SUSEstudio.com account, and what I'll do is I'll create a new image here, and I will select from a couple of templates that we have, and I will use a juice template, which is a just enough operating system template. It's kind of the bare minimum you can use to build an image. I'll also make sure to use a 64-bit image, and I'll give it a name. So once I've created this first configuration here, I can go in and make changes to my build. So the first thing I usually do is give the appliance a name or the image a name, and then I can go in and add additional software. So as you've seen in Ted's demo, he was adding Apache to an image, to a live running VM. What I can do here is I can pre-configure an image and, for example, add an Apache web server at the click of a button. So what will happen now is I can see that our system has gone in and selected all the depending packages as well as Apache itself and added it to that configuration. You can also go in and make a couple of other configurations here, such as networking or do some personalization if I'm building for other platforms. So I can not only build for Azure, but I could also build a disk image. What I could also do is overlay some files that are then put into the build process on top of this image. Because it takes a couple of minutes, I'll now start off a build process I'll just start with a USB hard drive image. So what will happen now is that our build farm, it's kind of a cloud in and of itself, will go in, schedule a job to this, take all the configuration that I've put in, and create an image. And after about a couple of minutes, it'll be done with building depending on the load of the system. So because this is a technical audience, I would think you guys are probably interested in how this actually works behind the scenes. So I've brought up this architectural slide here real quick, which shows all the different services involved in the SUSE Studio architecture. So what you can see up here on the left-hand side is the user accessing our SUSE Studio web app through HTTP. You can use your browser to access it. But there's a couple of other services, such as downloading images or accessing a live running instance of an image to making changes in a system that we call Test Drive. It's kind of a cloud service that we offer for free. On the other hand, it's also accessing software repositories out there, like in our OpenSUSE build service or Open Build service, where you can build packages for Linux distributions and consume them in the build process. And then there's also a couple of other systems in the back that communicate with each other for storing images, for doing the dependency resolution, and for actually then doing the build process. So I thought this would be interesting for you guys to look at while the actual build is running. So there seems to be some load on the system that's actually still waiting here, because I'd expected that I've actually built another demo that is already built. And what I can show you here is that you can have all different types of images available. You could build VMware images as well as live CDs or Zen images, disk images and stuff like that, built for EC2, but also since recently you can build for Azure and make sure you build one image and then use it in all sorts of different environments. What the system will also do in the back is to make sure that the image you're building is perfectly fit to that specific environment that you're building it for. So for example, for Azure, it will make sure to put the actual agent code into the image and make some changes so that it runs perfectly on Azure. Once an image is built, you can then upload it, but what I'll show you next before I'll show uploading is to actually make changes to an image. So what we have here is a test drive. So usually when you were building an image, you would have to download it, fire it up in some hypervisor, or deploy it to some computer. It's much easier to just use our test drive functionality here to start an instance of that image and access it using your browser or some other means, like SSHing to it. What you can see here in my browser is that I'm now actually starting the image that I've built here, and it uses some VNC connection to that, and you'll see it boot up. Or you won't, because it's failing here. Let's see. I guess we haven't sacrificed enough chicken to the gods of demo. We'll see. This one will be built in a second, and then we should be able to test drive off of that. Or just use another image that I have here. What we sometimes do to save space is when an image hasn't been accessed for a long time is that we expire it, but we still keep the configuration so you can rebuild it. That's another feature that's very helpful. While we're waiting for the build to finish, I'll also show you quickly our SUSE gallery, which is a gallery where you can publish images to a gallery site where people can discover images and then clone them and adapt them. So there's all sorts of applications ready to be deployed, and it's just a click of a button to take one of those pre-built images and then deploy them to whatever you want to deploy them to. Okay. So while the build is still running, I will just show you how easy it is to, when you have built an image, to actually then upload it. We have this upload button here, and after putting your credentials to SUSE Studio, so you kind of have to go to the Manage Credentials site to actually put your credentials in. This is done through the published settings files that you've probably dealt with when you have used the command line client that Tad was also showing. You can just upload these, select the storage service you want to upload to, and then save it. And what you can do then is select the version of your image build that you want to upload, and then just hit the upload button. Now our system will queue this upload, and even if it's a big image, the upload won't take a long time because we've optimized it quite a bit to make sure it's very seamless and easy to deal with. So once that is uploaded, you can actually uploaded. You can actually then go to the site to Azure and instantiate it up over there. Oh, let's see. So the upload usually takes about a minute or so to complete, and I'm hoping that this here finishes so that I can show you test drive. So it should just be another minute. So there it is. The image build took less than 5 minutes, which is okay for this type of build. I'll fire up another test drive here. And let's see. Well, there seems to be some issue with our test driving capabilities right now that is keeping me from showing this. What's really interesting is what we're doing is we're watching all the files that are being modified as the system is booted, and you can actually make changes to the image, take those modified files, and take those changes and put them back into the actual build process, which is sometimes really interesting when you look at a Linux distribution booting up and installing applications and seeing what's changing in that. You'd be surprised to see how much stuff is going on. It's a really interesting way to looking at what's changing. So concluding, let's look back at the upload. It's almost done, and the kind of next step then would be to actually head over to the Azure Management Portal, and with a small description here on how you could actually then create a VM from a build image from SUSE Studio. So with that, I think I'm almost out of time. And let's see. As soon as the registering is done, I would go over here to my Azure and take a look at all those images. As you can see, an earlier version, the version 001, has been uploaded already. I can show you and prove that this is actually working. So I could go to From Gallery, and then there's My Images tab, and you can see the Azure demo that I have here that has been uploaded last night. And I could go in, and as Ted was showing before, I won't go through this showing of actually building images and launching them in Azure, but I'll leave you with this. The version 2 is now also uploaded, and you can see how easy it is to actually put images online. All right, thanks.
Maybe? Yes, it is. Perfect. So, thank you very much, Christophe. I'm Nick Barset from Canonical. Together with Mark Louet, we're going to be talking a little bit on how you can run Juju on top of Azure. Who has heard about Juju here? One person. Great. A couple. No. So, we're going to go through very quickly through a few slides so that you understand what Juju is. So we think that in the context of the cloud, the old virtualization idea that one machine is equal to one image is not true anymore. We also think that managing machines are not exactly what people want to be doing in the cloud. They want to move toward managing services rather than machines. And Juju builds on top of Ubuntu to deliver exactly just that. We like to tagline Juju as being DevOps distilled. You must have heard about the DevOps movement, this idea that developers and operators should be working very closely together, should be forming one team, so that their common knowledge goes together. With Juju, we're offering the ability for people to actually write procedures that combine the best of their knowledge and share it with others. You can use a collection of these procedures, which we call charms, unmodified, directly from our charm store, or you can write your own. It's actually quite fun. To deploy a charm, it's as easy as it would be to deploy a package, and that will be the goal of this demo. Again, the idea of building a community that we use for Ubuntu is exactly the same thing we are trying to do with Juju. We're trying to build a community of DevOps that are sharing their best knowledge so that we have very up-to-date, very complete charms for all the workloads that you want to deploy on the cloud. Juju is something that we could summarize as being a service orchestration tool, but this term has been overloaded in many ways. So let's imagine that Juju is a tool that is going to allow you to manage service unit, connect them together so that you can focus on actually the workloads you want to deploy rather than on how to deploy them on the OS. We've got charms for about every workload that you want. And if you want to write your own, there is a lot of way we can help you with that. The way Juju works is that it's going to be exposing reusable units that you're going to be able to reuse time and time over. There is no thing in the charm definition that ties it to a particular deployment. Every connection is made so that the connection between two services are loosely coupled. So that, for example, if we describe that a service requires a backend as an SQL server, as long as the charm providing the SQL server provides the same interface, the SQL server could be anything you want. It could be Microsoft SQL, it could be PostgreSQL, it could be MySQL. The idea that your services can be described and loosely deployed. One thing that we didn't like in configuration management tool is that very often they were forcing you to learn a very specific language, what they call a DSL, domain-specific language. Juju is not written like that. You can actually write a Juju charm in whichever language you want, whether it is Bash scripts or whether you want to write it in C or in Python. You have complete freedom to implement any of the hooks that Juju provide in the language you want. So, in short, we want to make charms best practices that are reusable, that you can share, that you can deploy as many times as you want, wherever you want. And if you want to learn how to write your own, I invite you to go to juju.ubuntu.com/charmschool. There are charm school virtual and physical running all over the planet. So please come and join us. So enough of talking, and let's go a little bit more into the demo. And Mark, I think you should be mic'd up, so please go ahead.
Hello everyone. We'll be running a deployment of MongoDB on Juju. MongoDB, as you know, is one of the lead NoSQL databases, and if have anyone tried to install MongoDB in any platform here? Do you know that it's extremely complex to follow all the steps to actually get a MongoDB server running? I will show you how easy it is to do it with Juju. So all the comments that are needed to do these are exactly these ones. That's all. in 10 easy steps, well, even less than that, you can have your MongoDB database running. So first of all, we join Juju Bootstrap. What this will do is that it will start a virtual machine with all the environment you need to have Juju ready for action.
We didn't trust the demo gods, not enough chickens, so we recorded the demo, actually. It's in real time. Well,
Almost.
Who has used MongoDB here before? So one of the complexity of MongoDB is that it creates a ring of backend servers that needs to know about each other so that they can replicate between each other. And the complexity in the deployment is actually how am I going to inform this new server that I've just installed that there are others that exist that it should talk with, and vice versa, how do I inform the old one? And the notion of relation within Juju allows you not only to build relationships between two different charms, but also between charms of the same class. Therefore, automatically, when we are going to be adding units into the MongoDB running on Azure, the units will be informed of the actions they need to take to talk to each other.
So Juju talks Azure by default now. So we just deployed the platform. It'll be there run out, but we can see with Juju status that it takes some time for all the systems to get in place. So if we run Juju status right now, just after we've done the whole Bootstrap deployment, it will actually show you that the system is starting to get ready. So with Juju status, you can always see what's the exact status of your environment and if it's ready or not. The instance state is ready raw. That means it's almost there in Azure speak. So we'll just go ahead and start deploying MongoDB. So it's as easy as saying deploy MongoDB, and MongoDB is one of the charms available in the charm store. So the charm store is some kind of app store for charms where we actually are uploading the best of the best. So we make sure that every single charm that is on the charm store is the best one that we have for that role in special. So here we go. We've just deployed MongoDB. So what that has done, it has started another virtual machine, which we'll see here with Juju status. And this virtual machine will be the first node of MongoDB in our network.
So, as you hinted very rapidly, Juju works with Azure, but we didn't have to change a single line of code in the charm for MongoDB in order for it to be runnable on Azure. The idea is that Juju can talk exactly the same way to the charm, regardless of where you deploy. And today we support EC2, OpenStack, Azure. Well, Azure is coming. This is a preview. We also have a connector for bare metal deployment. So the same charms, you're going to be able to reuse them whatever the backend, the cloud or bare metal you want.
So once we've deployed MongoDB, as you know, every single virtual machine that you start doesn't open any ports to the outside. So Juju acts exactly the same way. We deploy the new MongoDB charm with your MongoDB database ready, but it's still not open for business. So in order to do that, we need to expose MongoDB. What that will do is that it will automatically open in your virtual machine all the ports needed for MongoDB to work properly and be able to be accessed from the outside. So it's as easy as that. We've already exposed the port. So now we have one node with MongoDB running, but that's not efficient enough. So we need to add more units. So in Juju, the add unit command, what it will do is it will just create more virtual machines and deploy more instances of MongoDB that will be automatically connected to the first one. So in essence, it will create a MongoDB cluster for you as easy as just adding more and more units. So it can be as resilient as you want. So here we're adding the unit for MongoDB. And as Nick said, Juju talks different providers and different needs from different charms. So here what it does, it will just call the add unit hook into the first machine. So it will actually do the commands that you tell him to do in order to add another machine in the cluster. So once we've done the add units, we can see with Juju status our whole MongoDB cluster working. So there you go. We have 3 MongoDB machines working on Azure in no time. So the MongoDB charm, the charms written in Juju, the descriptions follow the YAML standard. So as you can see, it's easy as just defining the providers and the peers. So in essence, MongoDB, what it does, it provides a database layer type MongoDB. So if you write any charm that uses MongoDB as a database backend, you can easily hook that with adding a relationship between your charm and the MongoDB charm. And everything will be done for you in order to set up this connection. And as you can see, MongoDB supports peers, as we just demonstrated, and the peers are demonstrated by the replica set interface.
So the peer relation is what allows us to grow the actual backend of MongoDB in no time. So here you've got a few ways to learn more about Juju. There is, I would say, the main Juju website, juju.ubuntu.com. The charms can be browsed over here. You can follow us on Twitter @Ubuntu Cloud, and we've also given our email addresses if you have any question that would pop up after this session. And I guess now we'll follow by Q&A global. Any questions? Yeah. Yes. Oh, yeah, of course. So the question was, are every MongoDB instance deployed in a separate machines? So Juju, by default, deploy each unit on a separate machine. So it will automatically spawn the instance, deploy MongoDB. One thing that Juju does, you specify which base OS image you want to use, and it will automatically do all the installation and configuration from there on. However, in some cases, you may want to have 2 services running on the same machine, and you've got the notion of subordinate charms that are meant to be running on the same machine as something else. So for example, if you wanted to have some auditing or some backup services running, you could do that as subordinates. Any other questions?
Okay, thank you very much.